Welcome back, my little penguins. New dead guy named Gay-Lussac. So dead French guy this time. He's got his own law, and here is what the law says. I have a gas in a firm container, so no balloon this time. Something like this, something like a tank where you fill happy birthday helium balloons. The gas inside of the tank pushes against the walls of the tank, and it exerts a certain amount of pressure, which I'm going to abbreviate with a P. The gas inside of the container also has a temperature, which I'm going to abbreviate with a capital T. What Gay-Lussac's law says is if I increase the temperature of the gas in the container, well, the gas has nowhere to go, so it's going to push against those walls even harder, and the pressure is going to go up. And conversely, if I make the temperature go down, if I cool the gas in the container, then the pressure is also going to go down. And that is basically Gay-Lussac's law. And again, it says a little bit more than that. It says that if I double the temperature of the gas in Kelvin, the pressure will double. If I cut the temperature of the gas in Kelvin in half, the pressure will go down by half. And here is the Gay-Lussac's equation, and it's going to look pretty familiar. Looks like Charles's law, except there's P's in the top instead of V's. So pressure 1, pressure at the beginning of the experiment, divided by temperature of the gas at the beginning of the experiment, is equal to the pressure at the end of the experiment divided by the temperature at the end of the experiment. Here is a sample Gay-Lussac's law question. It says, what's the new temperature of a tank of helium gas? So this is a tank where the walls don't move, with a pressure of 250 torr. So if the pressure is 250 torr at 0 degrees Celsius, and then you heat it up, and the new pressure is 1500 torr. So basically, you start out with cold gas, the pressure is 250 torr, and they want to know what temperature do you have to heat the gas up to inside of the container so that the new pressure ends up at 1500 torr. This is going to be P1 divided by T1 is equal to P2 divided by T2. That's Gay-Lussac's law. P1 is going to be 250 torr, and our T1, you better not be writing 0 degrees Celsius there. You better convert this to Kelvin. It's going to be 273 Kelvin, is equal to the new pressure, that's P2, that's going to be 1500 torr, and they want to know what's the new temperature. So that's going to be X, or maybe better thing to write is T2. And how do we solve for T2? The same way we do everything in this course. We're going to cross multiply and divide. We're going to do 273 Kelvin times 1500 torr is equal to the other part of the cross, which is 250 torr times T2. And we need to get the T2 alone, so we should divide the right side by 250 torr. We have to do the same thing to the left side, so we'll divide that side by 250 torr. The 250s will reduce away to 1. The torr units will cancel on the right side. The torr units will also cancel on the left side. The only unit that we have left on either side is Kelvin, which is what we want because we want to know what the new temperature is. So T2 is going to equal 273 K times 1500 divided by 250. And if we simplify that, that will come to 1638 Kelvin. That's the temperature that we have to heat the gas up to inside of the container to make the pressure go from 250 torr to 1500 torr. Now, I want to point out a couple of things. First of all, I said that when you do these kinds of gas calculations, you have to convert your temperatures to Kelvin to do the calculation. That doesn't mean that I will always ask for the final temperature in Kelvin. I could have said, what's the new temperature in degrees Celsius? And you would have to do the calculations using Kelvin. You would get a Kelvin temperature out, and then you would have to back convert this to degrees Celsius. And the way that you do this is, if you want to go from Kelvin to Celsius, you're going to take your Kelvin temperature and subtract away 273. So whatever that number is would be the temperature in Celsius. So for the calculations, you should convert all temperatures to Kelvin. But you may have to back convert to a different unit of temperature at the very end. So that is it for practice using Gay-Lussac's law. Next up is another dead guy, another famous dead chemist, but you're going to have to wait for that one. Okay, bye-bye.
your wings, and then you do a little